most of our time, maybe all of our time, on inclined planes. Is that okay? I know no, some of y'all weren't in class today, were you? Like some of y'all are in Monday's class, is that right? A few of you? Okay, so we started on that today. I did record that session. If you want to go ahead and watch that, that's fine. I mean, we're going to do that again on Monday. But just chapter 4 is a pretty big chapter. And I know that we haven't had much in-class activity. I just want to make sure that you're on board with that. Because chapter 4 is not an easy chapter. I want to make sure that you're prepared for it for the exam. So I want to practice a problem. We'll go and look at some of the old test questions. But let's just sort of make up a problem, because they're all going to look a lot like this. Whereas I have an inclined plane, looks like this, and I'll give it a certain angle. We'll say this angle is 30 degrees. I often use that angle. There's an object on here of mass m, and we'll say that the mass is, I don't know, 3 kilograms. Has a mass of 3 kilograms. Let's say that there's some force acting on this object, F. Let's say that the coefficient of kinetic friction on this object is 0.1, and the coefficient of static friction is 0.2. And then also I want to know what must F be in order to give me an acceleration equal to 4 meters per second squared up the inclined plane. Okay, so the question is, what is F? And this is a question, you can see this on the exam, something like this, or, you know, some portion of this really, you'll have a bunch of questions about inclined planes, and I'll ask you particular questions about the things as we go along. Like, what is the frictional force? What is the normal force? You'll see little bits of questions. And as you practice those questions on old exams, you'll begin to get a feel for what that means. As we're working with Newton's laws, there are several steps that you follow. Let me just outline those. These steps are always going to be the same. First is that you'll draw your vectors. Second, that you will resolve your vectors. If you're in 2 dimensions, you'll always have to resolve them into their x and y components. Third is that you'll apply Newton's second law, that the sum of the forces is equal to the mass times the acceleration. And then fourth, you'll solve the equations. And depending on your situation, you're going to have 2 to 3 equations. As we've done in the past, I'm never going to give you a situation where I have 2 equations that have 2 simultaneous unknowns. Just the algebra gets kind of tedious in that. But you can have multiple equations with multiple unknowns. I'll show you an example of that later. Okay, so in this problem, I'm going to first draw my vectors. On an inclined plane, the way you always draw your coordinate system is like this. I always draw my coordinate system so that the x-axis is parallel with the plane of the incline. I will have this is plus x, this is minus x, this is plus y, and then this is minus y. Now I want to draw all my vectors. And in that case, I just want to think about what are the forces acting on this. I have the force F right here. I also know that the acceleration of this object is going up the inclined plane. I told you that here. I have 3 other forces in this case. I have the weight of the object. What's another force that I have? Okay, but that's the weight, right? That's good. And what's another force that I have? The normal force. Very good. So I have the normal force acting here. And then this is a force, the fourth one that we didn't do in class today, but what is that going to be? The frictional force. Frictional force always opposes the direction of motion. Your frictional force will always be opposite the direction of motion. And since my motion is up, my frictional force is going to be in this direction. So I'm going to label it there as Fk. All right, I drew my vectors. I'm all done with that step. And next, I'm going to resolve the vectors. Before I do that, I have to figure out what is the angle for that one vector that's sort of hanging off on the side. And by the way, I chose this coordinate system because this coordinate system that's rotated has a lot of vectors that are on axis. That's why I choose that rotated coordinate system with the inclined plane, because it puts most of my vectors on axis. But that weight vector is not going to be on axis ever, because it's always going to be down towards the Earth. If this angle right here is 30 degrees, that means I need to know what this angle is. Notice that I have a little triangle here. And so if I have 30 degrees here, that means I'm going to have 60 degrees here. It's a 30, 60, 90 triangle. I'm going to redraw this, and when I redraw it, I'm going to resolve those vectors. So I have Fn right here. I have F here, Fk here, and now I need to resolve that weight into its x and y components. The x component of the weight is going to be Fw, what is it for the x component? Cosine, Fw cosine of 60. As you look back at some of my old exams, and maybe even in the notes, the videos that y'all watch, I might have done it where I measured the angle theta from the y-axis, in which case the x component is sine of 30. I just want to point out to you that if you see that in the old exams or the old notes, that cosine of 60 is the same as sine of 30. But I try to be consistent now. I always measure my angle from the x-axis, and then my x component will always be the cosine, and my y component will always be the sine. Okay, so I have that cosine 60. Here, this is going to be Fw sine of 60. I've done step number 2. I resolve my vectors. And now I'm going to apply Newton's second law. This is where I write my equations for the x and the y-axes. So Newton's second law applies both to the x-axis and to the y-axis. It's kind of like with projectile motion. When I treated the x and y velocities, or the x and y motions separately, you can do the same here. I'm going to write the sum of the forces in the y direction. That's going to be Fn minus Fw sine 60. That's going to equal to MAY. But AY is equal to 0, so this is equal to 0. That will always be true for inclined planes in the y direction, that the motion will have 0 acceleration, because your block isn't coming off of that inclined plane. And then the sum of the forces in the x direction, let's see, I have Fk plus Fw cosine 60. Minus F. It's minus F because F is on the negative x-axis over here. This is a negative x, so it's minus that value. This is a 60. And that's equal to the mass times the acceleration in the x direction. That's okay. And then there's a third equation here that doesn't come from Newton's second law, but it's just based on my definition of kinetic friction, that my kinetic friction is mu k times the normal force. Okay, so I'm looking for F. And if I look through these equations, I see that F is right here. And I ask myself, well, the question is, what here do I know? Well, I don't know F, and I don't know Fk, but I know everything else. So if I can figure out what Fk is, then I'm home free. I can answer this question. But I can answer it here because I know what mu k is. I don't know what Fn is, but I can figure out what Fn is. So my first step is to find the normal force. I'm going to start here, and I say that Fn is equal to Fw sine of 60. If I do that, Fw, remember Fw is m times g, so you just multiply your mass times 10. My mass here was 3 kilograms, so it's going to be 3 kilograms times 10 meters per second squared, gives me a weight of 30, times the sine of 60. And that's equal to 26 newtons. My normal force is equal to 26 newtons. I can take this and put it up here because my kinetic frictional force is dependent upon the coefficient and on the normal force. If any one of those increases, that increases my frictional force. I know F mu K, it was 0.1. So this is 0.1 times 26 newtons. So this is 2.6 newtons. And now, finally, I can figure out what F is. I take my sum of the forces in the x direction. Now I know everything here, and I solve that for F. F is equal to Fk, which is 26 newtons, plus Fw, that was 30 newtons, times the cosine of 60, minus m, which is 3 kilograms, times ax, and ax is 4 meters per second. But be very careful that my acceleration was in this direction, so it's going to be times minus 4 meters per second squared. Oh, wait, no, hold on. No, that's right. Okay. I have to keep that sign of the acceleration there. Yeah, I have to keep the sign of the acceleration. Okay? So whenever you're putting in your acceleration on this, make sure you have either is it positive or negative. That's going to be sort of something that'll trip you up on the exam, so watch out for that. All right, so now I get this, I'm all done. I have 26. I get 53 newtons. And that's the force that's required to make this thing go up at 4 meters per second squared. I know that seems like a complicated problem. There are lots of different pieces that go into it, but on your exam you would have that probably as several problems. Like I would give you that and I would say, okay, what is the normal force? Or what is the frictional force? And now what is the force that's pulling up? I want you to be careful because if you get one of those pieces wrong, it means that you might get the other parts wrong too. So make sure that you're practicing these and that they come pretty quickly to you, that you don't trip up on them. Go back during every exam. So make sure you're practicing all of those. But I want you to get those 2 or 3 or even 4 questions right. You want to look at some of the multiple choice type questions? They're all like this. It's just, they're all laid out slightly differently. All right, this is the Fall 19 exam. Like as I've told y'all before, the Fall 19 where I had these free response, these are great questions to work. Like this problem has 4 different parts. That would be like 4 different multiple choice questions. So I'm not going to work it here, but I'll let you go back and work it on your own. I'm going to skip ahead to the chapter 4 stuff, but obviously chapter 3 is still important too. Actually, no, I'm going to go back later. Let's go to fall. What y'all have 16, 17, and 18. We'll go to 15. This exam will almost be exclusively from exams 2 on the old exams. All right, like number 17. Let's look at number 17 and at number 18. This is the fall 15 exam 2. I have a 5 kilogram mass pulled up a smooth incline at a constant speed by a rope. The rope is parallel to the surface of the incline. The incline is 50 degrees. What is the tension in the rope? I worked through a problem like this in class today, I think. So I just want to find out what is the tension in the rope. I'm going to follow those steps again. Remember, draw the vectors, resolve the vectors, write the equations for F equals ma in the x and y directions, and then solve those equations. Those are your 4 steps, and they'll always be the same. Sometimes the second step for 1D problems you won't do because you don't have to resolve the vectors, but otherwise you'll follow always those steps. All right, so I'm going to draw my coordinate system, just like that. Now I'll draw my vectors. There's Ft. That's actually what I'm looking for. I have Fn, I have Fw, and thank goodness there's no friction. When there's no friction, the problems become a lot easier, so just be grateful for that. Though you will have questions with friction, obviously. It's an important thing. Luis.
How will you know when the question is asking for friction or not?
Well, this one doesn't say anything. Oh, no, actually, it does say something. It says that it's a smooth incline. That means there's no friction. But if I tell you that it's not, that it has friction, I'll tell you, hey, this has friction on it. Okay? I'll either tell you what is the coefficient, or I'll tell you the frictional force, or I'll be asking you what is the frictional force. Okay? All right, so I drew my vectors. Make sure I get my angle right. This is not 50 degrees. Gosh, what is this angle? It's 40, right. So hopefully all of this has become second nature to you now. Like, we've done this a few times, and so hopefully it just looks easy to you. Now, I'm going to redraw that. Even on the test, I recommend that you do this. Fn, Ft. This is going to be Fw sine of 40. And this is Fw cosine of 40. All right, so that's those are step 2, where I resolve the vectors. And now I want to look at what I'm looking for. I might not have to write all the equations, and in fact, I don't have to write all the equations here. Which equation do I need to look at, the x or y equation? The x, right, because I'm looking for the tension, and I see that I have the tension here, and I also know that I know Fw. I know that it's moving at a constant speed. What that tells me is that the acceleration in the x direction is equal to 0. So this is actually a pretty simple problem once I get up to this point, because I can say that the sum of the forces in the x direction is Fw cosine 40 minus Ft, and that's going to be equal to max, but ax moving at a constant speed is equal to 0. So now I'm looking for Ft, and Ft is going to be simply Fw cosine of 40. It's a 5 kilogram mass. That's a 50 Newton mass, because 5 times 10 is 50, times the cosine of 40. I get 38 newtons. Okay, there are lots of pitfalls that you can have. Let's see. Probably the biggest mistake the students would make is they would get the angle wrong. That they would do cosine of 50 instead of cosine of 40, and that would be one of those options. All right, let's look at number 18 too. I think you've already, I don't know if we did no one like 18, but you'll probably see one like that on the test. Any questions about this, Joe? I know this is sort of fast, but I think the more you see this, the more you'll be better prepared. Yeah, Jahan? Oh, so if you take the angle measured from the x-axis, your x component will always be the cosine. So that really goes back to this step right here. When I draw out when I resolve my vectors, when I take this vector and resolve it onto the x and y axes, I know that this is going to be cosine of 40 because that's my x component, and this is going to be sine of 40 because that's my y component. And then when you come down, applying in step number 3, applying Newton's second law right here, that's how you know that I have a cosine 40, because I'm looking at the x-axis in order to find Ft. And I know that I have to use that equation, the sum of the forces on the x-axis, because Ft is on the x-axis. And that's what I'm looking for, Ft. Okay? I see you shaking your head. And I understand that it might still be some confusion. But keep practicing, okay? I know that a lot of you are really confused by inclined planes, and that's okay. It's okay to be confused right now. But in 1 week, I don't want there to be any confusion, especially about inclined planes. This is probably one of the more difficult parts of the exam, but I'm telling you right up front that it's going to be on the exam. So I want it to be perfect when you get there. Can it be perfect? Can it? Perfect? It can be. It's possible. I want everybody to get these right. Let's look at number 18, because you'll likely have one like that too, where I give you an inclined plane, and I give you a series of equations, and I ask you which ones are right. There are a variety of ways you can do this. You could just write out all the equations and then compare them. But I find that as you get more familiar with inclined planes and working with these types of problems, then you'll see that you'll begin to sort of feel that which ones are right. You'll recognize them. Let's do like we did before. I'm going to draw my coordinate system like that. And then I'm just going to draw my vectors on it. They're really just doing step 1. I have my normal force here, Fn. I have static friction. It says that static friction is holding it on the plane. So that force is the frictional force that's holding it up. And then I'm going to go ahead and write out the x and y components. This is Fw sine of 60. And then this is Fw cosine of 60. I skipped a little step there that I did before, but I think that once you practice them a few times, you can probably skip ahead to that point. And then I also know that because the block is stationary, that the sum of the forces in the x direction and the sum of the forces in the y direction, that those will have to be 0. I can probably stop right there, and I can tell which equations are correct or not. Equation number 1, is that one correct? Fw cosine 60 minus Fs equal to 0, correct or no? Correct. Yes, very good. That one's correct. Fw minus Fn equals Ma. Not correct. Right. It would have to be, what would it have to be? Fn minus Fw sine 60 equals Ma. That could be correct if the A was 0, but this one is not correct, definitely. How about Fw cosine 60 equals Max? What's it missing? The other force. It's missing the frictional force. It should be Fw cosine 60 minus Fs. If that was it, it would be correct, but as it's written, it's not correct. And Fw sine 60 equals Fn?
Yes.
Yes, very good. Like the actual equation would be Fn minus Fw sine 60 equals 0, or equals MAY, but it's also true that Fn equals Fw sine 60. And when we have an inclined plane, when there are no vertical forces acting on it, that's always going to be true, that the normal force will equal to the y component of the weight. As I said in class today, I'm sorry, Emily, as I said in class today, you know, you can memorize some of the equations for inclined planes, and especially pre-meds. Like if you're doing that, that might not be a bad idea because you might see an inclined plane on the MCAT. It's just sort of a common physics problem. But I really recommend for this class that you just know the procedure and don't try to memorize all the equations because they change depending on the situation. Emily.
How do you know the frictional force is going in that direction?
Oh, good question. So it says here, you know, if there was no frictional force, what direction would this block go? Up or down the inclined plane? It would go down. And frictional forces always oppose the direction of motion. They always oppose the direction that the object would tend to go. And since this object would tend to go down the inclined plane, then the frictional force will be opposite that or up the inclined plane. Okay, good question. All right, so 4 was right? Wasn't that right? Yeah, so the answer is A, 1 and 4. Don't y'all love those questions where you have multiple options and you get to pick all the right options? Are you serious? That was a sarcastic question. There's lots of places to go wrong in those problems, okay? So be careful. All right. Let's do a different problem, like number 19. Caught a lot of flack over this problem, so let's work it out. An 8-kilogram mass is pulled across a smooth floor. No friction, smooth, no friction. Look for that word. The rope makes an angle of 28 degrees with the floor. Oh, let's do this one, and then we'll add some friction in, because it really gets better when there's friction in it, okay? But I want to know what is the acceleration of the 8-kilogram mass. Our procedure is going to be a lot the same as what we did before. We're going to draw our coordinate system and draw the vectors that are acting on it, resolve the vectors, and then apply Newton's second law, and then solve the equation. 4 steps. Let's draw the coordinates here first. I'm going to draw my vectors. I have 45 newtons at 28 degrees. I have a normal force, and I have a weight. And I want to know what is the acceleration. Next, actually at this point, you might be able to sort of skip ahead to the 3rd step. But let's go ahead and follow all the steps. Next, I'm going to have my normal force, Fn. I'm going to have F sine of 28. With the inclined plane, I did 90 minus the angle, but I don't do that here, right? Because before with the inclined plane, the angle gives you the angle between the y-axis and the weight, the angle of the incline, but here that's not true. So remember, with that, taking 90 minus the angle, that's only for the inclined plane. This is f cosine of 28. And then I have my weight, Fw. All right? And now I want to know, what is the acceleration? Well, the acceleration is presumably in this direction because that's the direction of the force. So really, I'm just doing the sum of the forces in the x direction equals max. And the sum of the forces in the next direction is really just f cosine of 28. And that's equal to max. I know everything in that equation. I can solve it pretty quickly. Ax is equal to f cosine of 28. That's 45 cosine of 28 divided by the mass, which is 8 kilograms. Now to give you my answer. Which I get 5.0 or 4.97 or 5.0 meters per second squared. Let's do this problem with friction. So let's say that we have a frictional force, a kinetic frictional force. I'm going to make it small. Let's say that it's 0.01. Oh, let me think right quick. So I think we can get away with 0.1. I'm going to make this to 0.1. All right, so I'm going to have a frictional force of 0.1. I'm going to go through and I'm going to draw in that vector right here. So now I'm going to have Fk right here. And so if I want to know the acceleration of this object, is it going to go faster or slower than it did before? Slower, right. So if I write the sum of the forces in the x direction again, now it's going to be f cosine of 28 minus Fk, and that's going to equal to max. And so the thing I need to do here is to figure out what is Fk. I know that Fk is equal to mu k times the normal force. So in order to do this, I need to figure out what is the normal force. You know, normally, the normal force is equal to the weight. Is that true here? Is the normal force equal to the weight? It's not true. It's not equal to the weight. Imagine that this object has a mass of, well, it has a mass of about 5 newtons. Or no, not even that, like a newton. It's like a newton. And so if I put it on the table, there's a normal force of 1 newton. But if I come along and I don't put a full force of 1 newton, let's say I pull up on it with a force of 0.5 newton, what is the normal force acting on this object now? It is 1 newton if I'm not touching it, but if I'm pulling up on it, what's the normal force? It would be bigger if I was pushing down on it, right? If I pull up on it with 0.5 newton, that means that the normal force is now less by 0.5 newton. And so that's what's happening here. My normal force is not equal to the weight. My normal force is equal to the weight minus this. And if you follow the steps, then you'll see that that's true. Let me show you. So if I do the sum of the forces in the y direction, I'm going to do it over here on the side. Sum of the forces in the y direction. Can y'all see that? Bailey, can you see it? Okay. Sum of the forces in the y direction, I have f sine of 28 plus fn minus fw, that's equal to 0. And then I solve that for fn, which is going to be the weight minus f sine of 28, which is going to be 80 minus, what was the force? 45 sine of 28. So I get 59 newtons. So my normal force isn't the weight, which would be 80 newtons. My normal force is something less. I can change the normal force on an object. It's not always equal to weight. If I have a downward force that increases the normal force, Or if I have an upward force that's less than the weight, I have a lesser normal force by that same amount. So I can figure out now my kinetic friction is going to be 0.1 times 5.9, or times 59 newtons, or 5.9 newtons. That is my frictional force, and now I can go back and solve that original equation. As I'm looking for the acceleration, it's going to be F cosine of 28 minus Fk divided by M. This is for AX.
That cosine 28 or 20?
Yeah, that should be an 8. Is that clear? Yes? Ladies? That's good? All right. So F is 45 cosine of 28 minus Fk, which I have now, 5.9. And I divide that by M, which is 8. And I get an acceleration of 4.2. Which is smaller than what I had before, and it should be because now I have friction acting on this object, which would act to slow down the object. Be prepared to do a question like that, because you will absolutely have a question either on an inclined plane or on a flat surface with a two-dimensional, with a force vector that's off-axis. That will include friction. Okay? It's going to be a very similar thing where you have to find the normal force in order to find the kinetic friction or the static friction, and then go back and apply it to figure out something about the motion of that object. Yeah.
How fast do you think you should be able to solve this? Like,
3 minutes? Yeah, like you gotta know it. So, yeah. You really don't want to spend more than 3 or 4 minutes. Y'all know, right? Is that true on the test? There's 28 questions on the test. So some questions come really quick, but I don't think any question takes less than a minute. Does it? Does some of them take less than a minute to fail? No. I know that's a lot to ask of you, but I mean, other people are going to ask you for a lot more. So I need a few minutes. And you know, it took me longer to do that here, but we're going through each and every individual step. But as you get good at it, you'll be able to skip some steps. But don't skip too many steps, because then you might just lose track of what you're doing. You can do it. Lots of people have gone ahead of you, and they've done it. You can do it too. You believe me? It's true. Lots and lots of people have done it, and you can too. As I told my class this morning, y'all are what? The second best students at the university? Were y'all in class when I said that? Y'all are the best students at this university. The best students in the state of Louisiana. You have great GPAs, you have great scores. Y'all are the best students. I know that you can do this. All right, let's if you come to questions on the second exams that have work in them, that's not our exam. That's chapter 5. Sometimes I did get to work in the second exam, but not this year. Particular questions I want to look at? Oh, can we do the elevator problem? Because that's another one of those questions that you're definitely going to have. I'm going to go to one with a figure on it. I had that question here, but I want to get one with a figure. It's easier to see. This is fall 14. Oh, here we go. We'll do this one. Then we'll put some numbers into it. So an elevator goes downward at a constant acceleration. What's the relationship between the weight and the normal force? If I have an object that's in an elevator that's dropping and accelerating, what is my normal force? Now, first of all, the normal force is the same as the weight that is read on a scale. So if you have a scale, what that scale is reading is not your weight. Right? It doesn't read your weight. It reads the normal force. In fact, if you're on a scale and somebody comes behind you and pushes down on your shoulder, what's going to happen to the weight that's reading? It's going to go up. Does that mean that your weight is increased? No. It just means that you have that extra force that's pushing down. So imagine if I'm in an elevator and I asked if it's accelerating down and you're standing on a scale, what's going to happen to the reading on the scale? Is it going to go up or down? It's going to go down because it's going to be like you're sort of lifted up off of the scale a little bit, and it's going to cause the reading on the scale to go down. So the normal force would be less than the weight. Now let's imagine, let's just give us a value here. Let's say that the acceleration is equal to 2 meters per second squared. Then what is the normal force? What is the reading on that scale? If I have this thing on a scale, what is it? Well, I know that if it wasn't accelerating, I know that that scale would read 100 newtons. And so if I have 100 newtons as an option, I would, you would know that it's not 100 newtons. And in fact, I would also probably have 120 newtons. And you know that that wouldn't be the right answer, right? Because that answer is actually more than the weight. So I could discard that answer. And I would also have 80 newtons. That would be the right answer, in fact. Because I would say, draw my forces, the normal force, the weight, say the sum of the forces in the y direction is equal to MAY. Sum of the force in the y direction is Fn minus Fw. That's equal to the mass times the acceleration. And I'm looking for Fn. So it's Fw plus Ma. And this is where you need to be careful about your signs. The sign for the acceleration. Fw is 100 newtons. I got that because Fw is equal to mg. That's 10 kilograms times the acceleration due to gravity, which is 10 meters per second squared. That's 100 plus 10 kilograms times the acceleration, which is 2 meters per second squared. But be careful because this is down, and so this is negative. Downward acceleration is negative acceleration. And so here I can get the answer, which is 100 minus 20 equals to 80. But a lot of people are going to put 120 for that answer. One, because they haven't just really thought about it, that if I'm dropping in an elevator, then my normal force should be less. And two, they're not really going to think about the math here. Even though they've gotten it right up to this point right here, they'll have a positive acceleration because that's what they would read. They would say, oh, the magnitude of the acceleration is 2 meters per second squared, but they'll neglect the fact that it's going down, which means it's in the negative direction. Now, when I give you a value like that, I'm giving you the magnitude, not the direction. Okay? As always, as with all the questions, make sure you go through and just think about the questions and see which of these are reasonable answers. Okay? I think we'll stop there. You guys look like you're all glazed over. Unless any pressing questions before we move on? All right, make sure you see me before you leave. I haven't gotten anybody's name yet because it came in late.